Today we're going to be going over climatic factors that will affect your design, and then after we'll be moving in looking at more detail climates and specifics, but we'll give a good overview today from chapter 5. So what are climatic factors as described in permaculture? So climate factors have the most profound effect on the selection of species and technology for your site, and they're the main deterrent of the plant and animal assemblies that we can use. So whether I'm in a tropical climate like Portugal here, or Honduras, and you would say, oh, well, Portugal could be considered temperate in certain elevations. So we're going to look at how elevation can change the different types of plants that may be available within our different climates. There's an intimate interaction between the site and the local climatic factors in that slope, valley, configuration, proximity to the coast, and altitude all affect the operation of the weather systems around us. So we can get within very narrow ranges, big differences in how a climate may affect our local growing conditions. So that's why it's so important to understand our local climate and then to design to specific local climate conditions. Such factors as fire and wind affect the site and any weather that's related to our site. It is the local climate that inevitably decides our sector strategies. So what here we're going to look at is how to overlay what is described in permaculture as wild energies. And wild energies could be any energy that's going to enter our site, and how we may look at how we can divide that into different sectors, such as fire. So if I have fire that's going to be from this direction, maybe in our sister site, Panya, in the north. They burn the jungles, the underbrush of the jungle each year. And they're right next to this, what you might call wildlife refuge area. So they have to be particularly careful about that fire sector. Every year when they're burning, they have to go out to make sure that, well, it doesn't burn down their place, right? So these are type things that they would need to design. So they could put particular species, like a row of banana trees. They're all water. That would be a good fire break. They're not going to catch on fire. So these type of species would adapt to that, not having, say, maybe the casuarina trees that we have here, because they drop pine needles and they're adapt to catch on fire. So these would be reasonings why we would pick different species. So although we'll be discussing the individual weather factors that will determine your climate, all these factors interact in a complex and a continuously variable fashion. Interactions are made more unpredicted by the long-term trends in your area. So we need to look at, especially with climate change today, climate weirding, what are the trends? Is it getting warmer? Some people say that our climate is now increasing in temperature, but there's other groups that say that little warming can bring on the next ice age. So if we're looking at the historic ice periods, this warming can bring down a drastic cooling. So are we in a short warm to a long cool, and what are we at? So we need to understand these trends. This is all based up about gases in our atmosphere. So CO2 being one of the hundreds of gases that would make up our climate and how it's going to be affected. And then any extraterrestrial actors. And this is not aliens. This is our sun, solar, radiation. So we want to look at the things that are actually driving the planet's mechanisms for heat. So the longer term trends, well, they're triggered by any relative interaction of orbits of the Earth. So how is our Earth orbiting the sun? What varying distance are we from the sun at any time will have a direct impact on our temperature. The sun and the moon, so then we have the moon when it orbits the Earth. It's not in an elliptical pattern. It actually shifts. It's more like an oval. So it has different distances. So dependent on the distance of the moon in its elliptical orbit, it also affects our weather patterns. So changes in these gaseous compositions, the Earth's atmosphere due to volcanism. So if we have a volcanic event, so a volcano erupts. We just had about a month ago, the volcano erupted in Bali. It's going to put in a lot of gas, a lot of ash into the atmosphere. And that actually has a cooling effect because it's going to reflect the sunlight. So in that instance, if it's a large enough event, what they believe may have ended the dinosaurs, for instance. Was that a meteor or was it a large volcano? And either way, the planet cooled. So these are things that are going to affect our agriculture and our forestry, dependent on these gaseous effects. Also the composition, understanding that now that we have this gaseous composition with various chemicals, this is what we kind of see today. About 82% of what we're here right now is carbon dioxide. Of that, we can get fluorinated gases, nitrous, and methane. And these are all coming from different places. So we can start to look at where are these gases being produced. Was it transportation? So 28% transportation, agriculture 10%, industry, commercial, electricity generation, And 32%, that's basically burning coal. So countries that are still burning coal to make electricity is pushing up and one of the major issues of CO2 today. But for us, agriculture, that's a very big thing. And transportation, a lot of the transportation is tied to agriculture. So we have any extraterrestrial actors such as meteors. So we could have a meteor shower. We could have any type of high-level atmospheric jet streams can change. They're subject to change periodically if we look at ice core samples. We have the oceanic circulation. It has fluctuations, and we even have magnetic fluctuations of the poles. And the poles, the magnetic poles on the Earth can shift. So they can actually go from positive to negative and negative to positive, and that's happened in the ice core sampling that we can see. So solar flares are also another one that a lot of people believe has one of the highest. They do have people on the planet that are not 100% sure that the carbon is what's making the temperatures. So the naysayers, if you will, point at solar flares, that the increased activity of the sun actually increases the temperature. So they're looking at that overlay. So that's something that you can look at.